got enough to go around, and the thought takes place uptown. I grew up on a sidewalk while on street talk, and then taught to Hawk, New York. I go to Queens for Queens.
Calvin cycle. Now, if you look at this, this is the chloroplast, this whole section, which has been turned into a 3D image, like this 3D model, and this is the light-dependent reaction, and this is the Calvin cycle. Now, we'll be focusing on only the Calvin cycle, as this project is the Calvin cycle. Now, as you all know, there are two types of photosystems, the reactions of the photosystems. Now, one's light independent and one's light dependent. Now, in this diagram here, this is the light dependent and this is the light independent. Now, the light independent reaction is the Calvin cycle. So this will be what we'll be focusing on, and then we'll run you through this. The Calvin cycle makes high energy compounds that can be stored for a long time. So unlike the light dependent cycle, the Calvin cycle will rather make a high energy sugar compound that will hold energy for a longer period of time. So therefore it is much more stable. The Calvin cycle takes place in the stroma, the region outside the thylakoid membranes. To put it real simple, the Calvin cycle begins off with carbon dioxide, and then it enters into the Calvin cycle right there, and then it goes around and around, and then when it's done with all the cycle, in the mid process of coming back to the first place, it will soon come back and produce a better energy source, such as in this case the Calvin cycle will produce sugar. The first step of the Calvin cycle begins with the 6th carbon dioxide molecule, which comes into the atmosphere, and then it starts to get through the cycle. It just tries to get through the cycle, and then on the way there comes the 5 carbon molecules right here, and then they combine on the way into the cycle, and then there comes the 12 3 carbon molecules. So the 6 carbon dioxide molecules and 5 carbon molecules are combined, which results with 12 3 carbon molecules. So it's going on the way a super 12 3 carbon compound on the way to the Calvin cycle. The second step of the Calvin cycle. Now, in the first step, we ended with the results of the 12 3 carbon molecules. Now, in the second step, the purpose of the step is to convert this 12 3 carbon molecule into even higher energy forms. So, in this process, the energy for this conversion comes from the ATP and the 12 NADPH. And the NADPH has very high energy electrons. So in this case, in the conversion, the ATP will change into ADP, and the NADPH will change into NADP+. So that's the second step. The 12 3-carbon molecules are changed into higher, even higher energy forms. So in this case, these two molecules.
This is a carbon molecule that has been converted into a higher energy form. This is an image of 12 3-carbon molecules. 2 3-carbon molecules are chosen from amongst them and taken away. These are not thrown away, but then used to produce sugars, lipids, amino acids, and other compounds. Going back to what's important. As you can see, there are only 10 3-carbon molecules left. These are then turned back into the way they were from which they came from. The cycle is then repeated. This is the Calvin cycle, which Melvin Calvin discovered.
World's greatest. Come on. Yeah. The world's greatest. I am a mountain.